Okay, welcome back. Let's continue on and we'll start discussing set operations. So set operations are where we want to combine different result sets together. And there's three common ones: union, intersect, and except. Sometimes we'll use minus instead of except, depending on the syntax of a particular vendor. These operations, unlike most in SQL, do automatically eliminate duplicates. So one type of operation there that we might want to use with a set operand is to find an OR condition, where we want to find all of the set of records with one set of condition, or all the set of records with a separate condition. So in this case, we want to find all the courses that ran in fall of 2009 or in spring of 2010. So remember that with set operations, you have to have the same arity. In other words, the same number of attributes in your result set, and the attributes have to have the same domain. So let's take a look at the answer to that one. So to find all the courses that ran in fall 2009 or in spring 2010, we do a standard select statement. Select course ID from section where semester equals fall and year equals 2009. Union, select course ID from section where semester equals spring and year equals 2010. So let's take a look at this one in SQLite. So one thing to note is that, again, this is where we do have some cases where there are some slight differences in syntax. In SQLite, you don't use the parens, whereas in Oracle you would. But otherwise, it's very similar. So we have the union for our conditions. We have two select statements, one for the first condition, courses that ran in fall 2009, select course ID from section where semester equals fall and year equals 2009. We're going to take the results of that and add to it the results of the second condition, or in spring 2010. Select course ID from section where semester equals spring and year equals 2010. We get the following courses, and these are courses that were taught in either fall or in spring. Okay, so let's return to our lecture slides. Okay, so another common query that we'll be asked to perform is with an AND condition. So we want to find the courses that ran in fall 2009 and spring 2010. This is more restrictive. In this case, a course has to have run in both of the semesters. And to do this, we'll do an intersect to get the result. So here we see the syntax from the book, which again is for Oracle, and we'll do a slight translation of that to put it into the syntax for SQLite. But you'll notice that we're using the intersect set operator. That's for and conditions. So we'll go back to our command prompt, and we'll put in our new query. And here we only have one course that was taught in both fall 2009 and spring 2010. So let's go back to our slides. Then we also have another common query where we want to find a set of results, except we want to exclude another set of results from them. And that's going to be the except or minus operation in SQL. So an example would be find courses that ran in fall 2009, but not in spring of 2010. So here's how we would handle that. We take the, we'd make a query for the first part, courses in fall 2009, and then we'd subtract out with the except courses that were in spring of 2010. So let's take a look at this in SQLite also. So here we have it. Select course ID from section where semester equals fall and year equals 2009, except take out any courses in that result set where the semester, where they also were taught in spring of 2010. And here the result set is Computer Science 347 and Physics 101. So again, null values are possible in our results. And the purpose of null values are that they signify an unknown value or that a value does not exist. So those are the two real purposes of nulls. And the result of any arithmetic expression involving a null is a null. So 5, if we're adding, some records together from different rows in a table, and one has a 5 for salary and the other has null, the result is a null when you do that type of addition. Now, there are some cases when a null will actually be able to return a value, and we'll take a look at those. The is null is something we can use to check for null values. So if we want to find all the records that don't have a salary so that we can take corrective action, we could say select name from instructor where salary is equal to null. So P is null is going to evaluate to true if there is a null value in the result set. So if we have an unknown and an OR operator with true, then we know the result will be true because it doesn't matter what the unknown value was. With an OR, if one of the premises is true, then the whole expression is true. The whole supposition is true. If it's a false or an unknown, then we get unknowns as results. With an AND, if we have a false for one of our premises, it doesn't matter if the other premise is an unknown, it'll still be a false, because even if the other was a true, it would be a false. So keep that in mind when dealing with nulls and the type of logic you might have with set operations. In addition to set operations, we also have aggregate functions. Aggregate functions are the type of data analytics that you want to perform on data sets that you have in your database. And SQL gives you a standard set of them, and we'll study some more data analytic capabilities when we get to OLAP and data warehousing later in the semester. But for now, We've got the ability to use things like average, find minimum and maximum, get the sum, or get the count of our records in a result set. So we might want to say, we might want to know the number of records in the course table. We could get that by doing a select count star on course, from course. Another type is like we want to get an average salary, or we want the total salary of instructors, or total of something, or the average of something in a table. So there we would use the average or sum, depending on which we wanted to get, a total or an average, on a particular field in that table. So let's look at a problem. Find the average salary of instructors in the computer science department. So select average, parens salary. That's the field we want to get the average on. From instructor, where department name equals computer science. And it'll give us the result. Might also just want a plain old count, a frequency count. So find the total number of instructors who teach a course in spring 2010. Select count, distinct ID from teaches, where semester equals spring and year equals 2010. Let's take a look at this in SQLite. Okay, so I'm going to shell out to do a clear screen. So let's do the average salary. So we'll select average salary. Oop, oop, oop. From instructor. Where department name equals computer science. And so we get an average salary of $77,000, pardon me, $333. We can also, in addition to getting an average on the entire table, we can subdivide the table into groups. And then we can get the aggregate function for each one of the groups. We could get a sum for each one of the groups, a count, an average, a min or a max, whatever the problem requires. But let's follow on with what we were doing before with average salary. So this time, find the average salary of instructors in each department. So we want it by department. We want average salary by department. That means we're going to group by department. So what a group by does is it sorts our table by the group by field. So in this case, it sorts it by department name. And then it puts in what we used to call in COBOL 50 years ago, control breaks. They had a similar function to this in COBOL that would let you do this not only against databases, but also index sequential files, and then flat files as well. But it's the same idea. This operation is going to do a sort, then it's going to set up a control break. Whenever the value of that sort field changes, you run the operation. So in this case, we're going to run the operation of average salary. And so we do biology, one record, we pull that over, 72,000. Then we have 3 computer sciences, we add them up, average, 77, control break, next we go to electrical engineering, and so on. So again, with the group by, what we have is we sort put a control break in, and then perform our operation. In this case, it's an average on that. Let's do the same thing in SQLite and see what we get. So we'll do select department name, comma, average salary, from instructor, group by department name. And there's our results. One thing to note is that any fields in the select statement must be in the group by statement unless you're doing an aggregate on that field, like we're doing an average on salary. So here again, attributes in the select clause outside of the aggregate functions themselves must appear in the group by list. So let's take another example. Find the names and averages of all departments whose average salary is greater than $42,000. Well, to do this, we're going to need the having clause. Let's take a look at the answer here. The having clause is similar to the where clause. The where clause lets us select records from a table based on a condition. The having clause lets us select the records from an aggregate operation based on a condition. So if you're going to be selecting records based on an aggregate function like average, use the having clause. If you're just selecting records directly from a table and you want to filter them with a condition, use the where clause. So it's very simple. We have it's the same syntax as before. Select department name, average salary, from instructor, group by department name. That's the same as it was before. We add in the having clause, having average salary greater than 42,000. So this is going to return the names and average salaries of all departments, and it's also going to filter them on a condition greater than 42,000, so it only shows those. Let's take a look at that in SQLite as well. So we'll run this other query again. Oops, that's not it. Group by department name, having AVG salary greater than 42,000. And here you can see we got rid of the music department because their average salary was less than 42,000. So again, note that when we use the where clause and when we use the having clause. The having clause is done with group bys and aggregates. And the where clause is used directly from the table itself. So with nulls and aggregates, what happens is the aggregate operator will ignore null amounts. So it'll give you the average salary, for example, or the sum of a salary. If a salary is there, it'll add it. If it isn't there, it just goes on to the next record. Nested subqueries let us handle more complex questions and are based on the idea that every query itself returns a table. Remember, we said that in relational algebra, every expression that we have, every relational algebra expression takes one or more tables and returns a table. And we also said that in SQL, every SQL query takes one or more tables and it returns a temporary table without a name. So we can take advantage of that and create subqueries. So here's one that we used the intersect operator on earlier. Find all courses offered in fall 2009 and in spring 2010. Well, with a subquery, we could do it like this. Select course ID from section where semester equals fall and year equals 2009, and course ID from what we're getting is in this. Select course ID from section where semester equals spring and year equals 2010. So this is going to return a table of course IDs. Remember, it returns a temporary table of course IDs that meet the criteria spring 2010. So that course ID, the course ID here is going to meet the criteria fall 2009 and spring 2010. And we can take a look at this in SQLite. So I'll switch to SQLite. And here's that query. Select distinct course ID from section where semester equals fall and year equals 2009. And the course ID is in this temporary set we get back from this query. Select course ID from section where semester equals spring and year equals 2010. And of course, we get the same result as we did with the intersect operation. Two different ways of programming for a particular result. Okay, let's switch back to the slides. And we can do the same thing, but with the exception that we want to exclude courses that were taught in spring 2010. So find courses offered in fall 2009, but not in spring 2010. So again, we're going to do, this is like a set operation. We have the first set is the ones that meet this criteria, fall 2009. Then we want to get rid of any of those in this fall 2009 that were also taught in spring of 2010. So it's very similar to the query we just did, except that we have a not in with our subquery. So let's take a look at this in SQLite as well. Okay. So again, this is very similar to the previous query, except we have not in. So let's take a look at this in SQLite. Again, our first condition is in the where clause, and then in the where clause, we use a subquery to return a temporary table with course ID that also has the second condition, spring 2010. And in this case, we're going to subtract that out of our other intermediate result set And what we get then is a result set where you have courses that were taught in fall 2009, but not in spring of 2010. Okay, we'll go back. Okay, and we might want to find courses that students have taken that were taught by an instructor with a particular ID. So this again is going to be using subqueries, and we can take a look at it here. Very, very similar to what we have been doing. This is where again some of the syntax is a little different in the various vendors' offerings. Oracle is different from Microsoft SQL Server, which is different from SQLite. So let's go ahead, take a look at this in SQLite. We'll trim that down to just course ID, not in the query, and then SQLite will be able to handle that. One thing to note, SQLite is a 500K database engine, and Oracle and Microsoft SQL Server are 5 GB database engines. So with SQLite, you get a nearly full-featured, robust database management system, but it's not going to have everything. At 500K of disk space, you get a lot, but you don't get it all. With Oracle and Microsoft with 5 GB of data space, you get it all. So here's one of the examples. We'll use just a single field in the comparison with our subquery. And of course, that's fine in this particular case, and in most cases. Okay, so another type of set operation is a sum. So we want to have a condition where some operation on a table is greater than that of some in perhaps another group or another table. And that's where we use the query with a sum clause. So in this case, we would select distinct T name from instructor as T, instructor as S. That way we can compare the various groups within the instructor table. And we do that in our where clause, where T salary greater than F salary and department name equals biology. Another way we could do that is with the sum word in the where clause, where salary is greater than sum, and then select salary, and we have a subquery in there. So again, this is an ability to do the same requirement different ways in a programming language like SQL. So with a sum clause, what we have is 5, for example, is less than sum in a result set. And this would be true if the result set was 0, 5, 6. 5 is actually less than 6, so it is less than some of them. 5 is less than sum in this second result set, 0, 5, is not true, because 5 is not less than 5. 5 equals sum in the result set 0, 5 is true. 5 not equal sum in the result set 0, 5 is true also, because 5 does not equal 0. So in effect, sum is the equivalent of in. However, as we see in this last example, 5's not equal to sum is not the same as not in, because here 5 is in this result set, but 5 is definitely not equal to sum of the result set as well. Another option where we can We have alternatives to the way we had been doing it, where we would make two instructor tables, temporary tables like we did up here, instructor as T, instructor as S, and then do a comparison T salary greater than S salary. We didn't have to do that, the rename of the instructor table twice, so we could use it twice in our operations as separate tables, because here we used it in a subquery. So again, it's your choice of which approach you take. And we have the same thing with all. So we might modify the name of all instructors whose salary is greater than all of the instructors in the biology department. And so here we would do salary greater than, we have a subquery in here. One thing to note is that not all of the database vendors support some and all syntax. But they all do support the idea of creating multiple versions of a table and then comparing groups in those versions to get at your answer. Okay, so again, with the all clause, 5 is less than all of these, false because it's not less than 5 or 0. 5 is less than all of these, 6 and 10, that's true. 5 equals all, 4 and 5, that's false. 5 does not equal all of these, 4 and 6, that's true because it's not equal to them. So not equal, not all, not equals all is the same as not in. But equals all is not the same as in. Because here, 5 is in this result set, but it does not equal all of that result set. Sometimes we might want to test to see if a subquery returns any values or not. And so we can use the exists word in our where clause to test that. So here's, and we can go on and do subqueries in the from clause as well. So again, the from clause is where we designate tables. If we have a subquery in our from clause, then in fact, that's going to be treated as a table. And here we can then use a subquery. The result will be a table with the 2 columns, department name and average salary, and then we can do a where clause on that temporary table. This is a way of doing the same thing using a subquery that we use the having clause without a subquery. Okay, so again, let's take a look at our schema, and we'll look at doing another hands-on. Take a couple of minutes and do this exercise, then we'll go over it in SQLite. Okay, welcome back. We'll take a look at this one. Switch to, well, we'll switch to SQLite. So we want to find the names and ID of students who have not taken any course offering before 2009. So they've taken courses after 2009 only. So the way we do that is we select the ID and name of all students, and then we subtract from that result set the ID and name from students, and we natural join with takes, where the year in takes is less than 2009. So this is going to subtract out any students who had a course prior to 2009. So we can find out all the new students in a particular class or in a particular department. So in this case, we're looking for new students in a department, and this is the result. For even more complex queries, we can use the with clause. And that will enable us to define a temporary view. And that view definition, though, is only available to the query in which the clause, the with clause, occurs. So, for example, we can create a temporary virtual table, also known as a view, called max budget, as select max budget from department. So that way we get the maximum budget from the department. And then we can answer this question, find all departments that have the maximum budget. So then it becomes simple. Select budget from department, comma, max budget, where department dot budget equals max budget dot value. And we named the column in max budget value up here. So again, this is another way we could have done it, and we did, in fact, in earlier slides, do this a different way, but it's another way of doing it. Another example, find all departments where the total salary is greater than the average of the total salary at all departments. So here we make one temporary view, or in other words, a view is also a virtual table. So we're making a temporary virtual table. And we give it a name, and we give the column values names as well. And again, it's going to be based on a subquery. And then we can use this temporary table or virtual table or view in a second definition, where we would say department total average, comma, value as select average value from department total. So we're using this temporary view here to create this temporary view that we in turn use down in our actual query. Select department name from department total, comma, department total average, where department total dot value is greater than or equal to department total average dot value. So again, this is just another option for you to solve problems. Nothing says you have to do it this way. It's just available for you. Now, we won't be doing too much with modifications of our database in terms of updating, but it's very similar to what we do with our queries. So if we want to delete all the instructors, it's a simple delete from instructor, and that will get rid of them. Just like with a select statement, though, we can use conditions on our deletes. So let's say we only want to delete all instructors from the finance department. So we would say delete from instructor where department name equals finance. And we can get even more complex and use subqueries in the where clause of our delete. Delete all tuples in the instructor relation for those instructors associated with a department located in the Watson building. So delete from instructor where department name in our subquery. Select department name from department where building equals Watson. Another example, delete all instructors whose salary is less than the average salary of instructors. Well, here again, we can use a subquery as one option in our where clause. We could also, again, use a having statement if we wanted to. So, well, let's use the where statement in our subquery in our where statement, delete from instructor where salary is less than, select average salary from instructor. So what SQL does in this case is it's going to compute an average salary, and then it's going to find all the tuples less than that and delete them. It doesn't keep a rolling average salary, because then it's probably not what the user was interested in. Inserts are very simple. You say insert into your table, let's say course, and then a set of values. And then we give the values for all the fields, all the columns in the table, including null if we don't have a value. We can also say insert into course and then parens and list each one of the column names and then the values that we're putting into those columns. So if we wanted to, for example, add all instructors from into the student table and set their total credits equal to 0, we could say insert into student. We have a subquery here, select ID, name, department name, 0 for the credits from instructor. Because again, student has this, the first three are the same, ID, name, and department name. Total credits is what the student has in the fourth field. Instructor has salary, but we're only taking the first three fields from instructor and then placing a 0 in for the total credits. We can also update fields in our record, in our tables. And we do that with the update command, update instructor. In other words, update the name of the table. Set salary, which is a field in instructor, equal to salary plus 3%. If their salary is greater than 100,000. Another example, update instructor, set salary equal to salary plus 5% if the salary is less than 100,000. So again, a schema for our university database, and let's use that in answering this question. Take a couple of minutes and work on this one, and then we'll come back and go over it and call it an evening. Welcome back. Let's take a look at this in SQLite. So we want to find the course ID of all taught courses where the course ID contains the numbers 101. So here we're going to, of course, select course ID from the table teaches, where course ID like, we're looking for a pattern, and the pattern is we want to have 101 in the course ID somewhere. So we have the percentage sign before and after, and the result is we get these courses with 101 in the ID. Okay, thank you. See you next lecture.